In section 2.2, we're going to look at more graphical styles and displays. The first of which is going to be the stem leaf plot. A stem leaf plot is a display that organizes data to show its shape and distribution. A stem and leaf plot looks something like a bar graph, where each number in the data is broken up into a stem and a leaf. The stem of the number includes all but the last digit, and then the leaf of the number will always be a single digit. For example, if we have, let's say, 20 statistics students grades on test 1, we have all of this data. We could take this and sort this into a stem leaf display to kind of see what the shape of the data would be. Typically, whenever you have a stem and a leaf plot, you need to kind of determine like what the stem is going to be and what the leaf is going to be. You can either give a verbal description of that, or a more common practice is to give a key. That way people kind of know how to decode from the stem leaf plot to know what each individual value represents. For instance, a stem of 6 with a leaf of 0 would correspond to the value 60. Okay. One of the things that will oftentimes be very helpful when you do a stem leaf plot is to have your data sorted into the calculator. So first thing we would want to do is to go ahead and enter all of this data in. You would go to Stat, Edit, and then under list L1 I have all of my 20 values already in here. I now want to go ahead and sort this, so I go to Stat. We're going to do Sort Ascending, and then I want to use list L1. So I'm going to do second 1, parentheses, enter, and now my list is sorted. You could either go back to the Edit menu, and now we see that all of those values are in there and sorted, or alternatively, if I go to the home screen, I can just put L1 on the home screen by hitting second 1 and then hit enter, and that will allow us to scroll from left to right, or vice versa. To start with our stem leaf plot, what we want to do is we need to determine what is the minimum and the maximum of our data set. The minimum is 60. That's going to have a stem of 6. And we go all the way up to someone got a score of 100. That would be a stem of 10. So by knowing the minimum and maximum, we know what stems we're going to need to use. And you always kind of put the stems in descending order, so 6, 7, 8, 9, and 10. Furthermore, let's suppose, hypothetically speaking, if I had a value that was missing in the 80s, so even if there were no 80 scores, you would still need to put that stem there. There would just be no leaves across from it. So please make sure that whenever you do your stem leaf diagrams, that you have every stem from the minimum up to the maximum, even if one category happens to be missing values. From there, again, using the sorted list, this is going to make things easier on us. I have 3 values that are in the 60s, 60, 64, and 69. In the stem leaf plot, that's going to correspond to the stem of 6, and then you just put the last digit for each number in increasing order. So 0, 4, and 9. These entries here in our stem leaf plot represent the 3 numbers 60, 64, and 69 from our data set. The other important thing that will come into play when we start to go to our stem of the 70s is that the number 70 itself gets repeated twice. Every time, or for every instance a number occurs, you have to write its leaf repeated. So I have to put the 2 zeros here to represent the fact that we actually have the number 70 occurring twice. The next value would be 71, so I put a stem of 1. 72, put a stem of 2. 75 occurs 2 times, so I need 2 5s, 1 for each of the 75s. And then I finish with 78, so an 8 goes there. You just kind of continue this. The value 80 is a stem of 8 with a leaf of 0. With our data now sorted into the stem leaf plot, we can answer some pretty basic questions. What can we conclude from the data set? Well, it seems like most of the students kind of scored in this range here. So the majority of students scored between the 70s and 80s. Okay. We can also quickly determine that the minimum was 60, the maximum was 100, and in terms of the shape of a distribution, this is something we'll get to later in the class, but it kind of has like almost like a sideways bell shape to it. And we're going to call that a normal distribution here in a while. In example 2, they ask us to use the stem leaf plot to list the actual data entries. So here we have yet another data set, and the key in this case tells us that a value of a stem of 0 and a leaf of 8 would translate to 0.8. So here the stem is the ones digit and the leaf is going to be the tenths digit. So we already know that 0 with an 8 corresponds to 1.8. The next row would be 1.5, 1.6, 1.8. We have 2.1, 2.3, 2.4, 2.5, 3.0, 3.9, and also 4.0. So by having that key, again, the key is very essential. Just a stem leaf plot by itself is not informative. You always should give a key or describe how to translate it, give definition to what the stem means and what the leaf means. The next type of diagram we're going to look at is what's called a dot plot. A dot plot is another visual way that allows us to see the shape of the distribution. Here, each data is plotted above a number line on a horizontal axis. For example, let's suppose we have the scores of 14 students on their math test, and they ask us to use a dot plot to display the data. The first thing you would want to do, and you actually don't need to do this with a dot plot is pretty straightforward. It's not one of those ones where you absolutely have to sort it, and I would probably not even bother doing it. But one of the things you do want to determine when you're doing a dot plot is what is your minimum value and what is your maximum value. If we look at this data set, just kind of quickly glancing through, the minimum value is 68. The maximum value is 95. And now what that'll kind of allow us to do is to determine a scale that we kind of think is appropriate that includes the min and the max. I would probably be inclined to maybe count by fives, starting down below at 55, working our way all the way up to 100 or 95 you could even stop at, or you could even count by tens. But simply put, all you're going to be doing is for each value you have, for example 72, I would simply go to my number line, wherever 72 is located at, and I would make a dot directly above the number line to plot 72. For the value 80, I would do the same thing. I'd come over here, wherever the 80 is, go ahead, plot, make a dot, and then just keep going through the rest of your data set. 95 would be over here, make a dot. 82 is roughly about here, and then you just keep on going. The only thing you have to keep in mind is that whenever a value gets repeated, for instance, by the time I get to this number here, not that number, right here. By the time I get to this number, 95, this is my second 95 in my data set. And the way that that gets visually represented using a dot plot is you just are going to make a second dot directly above your first one. And then for every instance of that number getting repeated, you just simply keep making dots above the 95, going up. So this would be our dot plot when it's all put together. It's a nice visual description that kind of allows us to see the shape of the data set. Here for this particular class, it looks like the grades just kind of cluster in two regions. You have a lot of people between 70 and 82, and then you also have a second group of students that kind of cluster between 80 and 95. And then we also see that there's kind of this one outlier, this one individual who scored all the way down at 58. So again, just looking at the numbers, it's not easy to kind of make inferences and to spot patterns, but when we create these graphical aids, it really kind of gives us some insight and some view into what the data set, how it's spread out. The last type of chart we're going to look at in section 2.2 is your classic pie chart. It's a circle chart that provides a visual concept of a whole. So in the pie chart, you're able to compare the size of each category to the entire data set. You might recall that a circle, if you have a circle geometrically, has 360 degrees, and so 100% or all of our data set will have an angle of 360 degrees when we plot it in a pie chart. The pie will be divided into slices, where each slice corresponds to a category, and the size of the slices is proportional to the frequency of the corresponding category. So to construct a pie chart, these are the steps you would want to take. We first want to change the frequency into relative frequency. We've done that earlier in the class, but what you would do is you just take the frequency of the class, divide it by the total number of values, and that would give us the relative frequency. That's kind of the general proportion of the data set, or the size of the circle here in a second, that each class will take up. From that, we then want to determine the central angle for that category. A central angle in a circle is simply any angle whose vertex is at the center. The central angle is found by taking the relative frequency from a moment ago and multiplying it by 360 degrees. For example, suppose we have a sample of adolescents that were asked to identify their music preferences. The following data was constructed. Let's see what we have. So we have rap, alternative, rock and roll, country, and classical. These were our 5 categories. 147 people preferred rap, 87% preferred alternative, 68 for rock and roll, all the way down to 13 for classical. The first thing we're going to need is the relative frequency for each class, so we're going to need to know the total. If we add these all up, there was a total of 350 people that responded to the survey. The relative frequency for rap is found by taking the frequency, 147, dividing it by the total of 350, and that would give us 0.42. Likewise, for alternative, you take 87, its frequency, divided by the total, 350, to 2 decimal places, that gives us 0.25. We continue for the remaining classes to get our relative frequencies, and then what we're going to do is now we're going to convert them to angles. You simply take the relative frequency, in this case for rap it's 0.42, multiply it by 360 degrees, and that would give us about 151.2. We will always round to the nearest angle, so that's going to be 151 degrees. For alternative, it works out nice and clean. If you take the relative frequency 0.25, multiply it by 360, 0.25 or a quarter of 360 would give us 90, and then just continue to repeat this for the rest of them. 0.19 times 360 would round to 68, 0.10 times 360 would give us 36, and then 0.04 times 360 would give us 14. And then from there, what we can do is we can go ahead and draw our pie chart. For the pie chart, the angles themselves, the angles are measured according to our central angle that we found a moment ago. If you have a protractor, you can measure these very nicely. For us, if you have to do a hand sketch, just give a rough ballpark estimate. I'm not going to check everybody's angles to make sure that they're perfect on this. But the largest category we see is rap. It would have a central angle here of 151. And then when you label the chart, just make sure that you actually label it not using the angle, but using the relative frequency expressed as a percent. So 0.42, move the decimal spot 2 places to the right, would be 42%. For rock and roll, move it 2 places to the right, 19%, country is 10%, classic 4%, and alternative would be 25%. And correspondingly, if you're looking at the size of these wedges, the central angle, this is our 90-degree angle here. Rock and roll would have a central angle of about 68 degrees. Country has an angle of about 36. And classical would have an angle of about 14. With this pie chart in place, we can now answer some basic questions. What would you conclude about the data? We can conclude that the most popular category was rap.